There are invisible tides slowly reshaping entire galaxies right now. They are gravity, dark energy, and cosmic magnetic fields. The immediate truth is simple, unseen pulls decide cosmic structure. This matters because those pulls decide where stars and planets form. Gravity pulls matter into deep, dense wells over long times. Magnetic fields guide charged gas along invisible lines. Dark energy accelerates expansion, and it thins large structures. For example, the Milky Way's bulge packs about 100 billion stars. Quick recap: unseen pulls quietly remake the universe's structure. A swirl of stars and dust fills a wide panorama. Gravity is the attraction between masses that gathers matter together. This matters because gravity builds stars, forms galaxies, and sculpts structure. Imagine space like a stretched sheet that mass dents deeply. Objects roll toward those dents, and matter flows inward over time. Dark matter deepens wells, and visible gas falls in to form stars. For instance, the Milky Way's bulge hosts roughly 100 billion stars. So the picture is simple: gravity builds the cosmos skeleton. A tight shot shows glowing filaments around a star-forming knot. Magnetic fields are invisible lines of force threading cosmic gas. You should care, because fields change how clouds collapse into stars. Fields exert tension and pressure, and they resist compression of gas. Charged particles spiral along those lines, and currents can twist fields stronger. In molecular clouds, magnetic pressure can slow collapse by roughly half. Orion shows aligned dust grains tracing fields across tens of light years. Net result: magnetic lines quietly steer where new stars appear. A vast cosmic web stretches from horizon to horizon. Dark energy is a uniform repulsive effect accelerating space's expansion. This matters because acceleration limits gravity's ability to gather matter. It acts like pressure in empty space, increasing expansion over time. As expansion speeds up, density contrasts stop growing significantly. Distant supernovae revealed acceleration about 6 billion years ago. After that epoch, galaxy clusters stopped growing much larger. Bottom line: dark energy thins the cosmic web and isolates galaxies. A lab-style view shows detectors scanning a faint cosmic glow. Radiation backgrounds are baths of photons and energetic particles filling space. You should care, because radiation controls cooling and chemistry in gas. High-energy photons strip electrons, and they change cooling efficiencies. That alters how clouds collapse, and it can prevent star formation. The ultraviolet background kept many small halos dark for billions of years. X-rays from early black holes ionized and heated gas far from sources. Quick anchor: cosmic radiation dictates when and where structures can grow. A scene of expanding shock fronts shows shells and supernova flashes. Stellar feedback is the combined push of winds, radiation, and explosions. This matters because feedback regulates star formation and redistributes gas. Feedback injects energy and momentum into the gas. It heats and stirs the interstellar medium into turbulence. Supernovae create hot bubbles that break out of galactic disks. Typical galaxies can expel tens of % of their gas mass. So remember, stars push back, shaping future star and planet formation. A close-up of dust grains reveals tiny actors with outsized influence. Dust and chemistry provide raw materials and cooling pathways for planets. You should care, because dust controls planet formation and organic chemistry. Grains stick together and grow into pebbles in disks. Collisions build kilometer-scale planetesimals over thousands of years. Dust shields molecules, enabling cold chemistry that produces water and organics. ALMA images show rings where dust concentrates, forming planet seeds quickly. Remember, microscopic dust determines macroscopic planetary outcomes. A sweep across a galaxy cluster reveals bridges and stripped tails. Environmental effects are external forces from neighboring galaxies and gas. This matters because most galaxies exist in dense groups or clusters. Ram pressure strips cold gas when a galaxy plunges through hot cluster gas. Tidal forces pull stars and gas into long streams during close passages. Mergers funnel gas inward, igniting central starbursts and rapid growth. The Virgo cluster shows dozens of galaxies losing billions of solar masses. So the picture is clear: neighborhoods largely determine galactic destiny. There are invisible tides and pushes that rewrite cosmic history. Each force, gravity, magnetism, dark energy, radiation, and dust, plays a role. The payoff is practical. Together they decide where stars and planets form. If you follow these forces, you can read the universe's assembly like a map. Remember the opening claim, unseen pulls quietly reshape everything. If you enjoyed this calm cosmic story, please subscribe for more.